Hello students, I hope all of you have watched the previous lesson. I hope you understood the concepts, and also I suggested you to write the notes. I think by this time you have completed your notebook work also. So let us have a recapitulation of the data what you have learned in the previous class. The first we have discussed about electric current. So what is electric current? Can anybody give the answer? What is electric current? Yes, electric current is the rate of flow of charges. Very good. And we have seen an equation, small equation for the electric current. Can anybody else say? What was the equation? I is equal to, yes, I is equal to Q by T. So what was Q there? Charge, amount of charge. Then T, the time. So the unit which we have learned to measure charge was Coulomb. The time was second. Therefore, I can be Coulomb by second or Coulomb per second. And at the same time, a single unit I told you. What was that for the electric current? In single word, 1 unit. Yes, ampere. So also you have learned to define 1 ampere. So 1 ampere is 1 Coulomb by 1 second. Therefore, 1 ampere is that current passing through any material if 1 Coulomb of charge is flowing in 1 second. This definition also we have seen. And next we have defined electric potential energy. We have defined this as the amount of work done to bring a charge from one point to another. So that work done is the potential energy. Since it is for the charge, we have renamed it as electric potential energy. So 9th standard you studied about potential energy. There you were dealing with the mass. Therefore you have used only the word potential energy. But since here it is charge, we have called it as electric potential energy. Under that, we have defined yet another quantity which is called as potential difference. So can anybody say what is the definition for potential difference? Yes, it is the amount of work done in moving a charge from one point to another point. So there is 2 fixed points if we are taking. Between these points, if we want to make a charge to move, how much work we have to do, that is known as potential difference. So the letter V we used to denote potential difference, and the potential difference V is measured in a unit named volt, and since it is work done, so we can take V as W by Q. I hope all of you remember this equation. So what is W here? Yes, work done. What is Q here? Charge. So work done per charge. That is called as potential, or if the 2 points we are fixing, that potential we can call it as potential difference. So these 2 physical quantities we have defined in the previous class, and these 2 things correlated in a particular law. That law we have learned, that law is Ohm's law. Yes, can anybody tell me the statement for the Ohm's law? Okay. Oh, what it is? Yes. One condition we have to tell before giving the statement. The condition. What is the condition? Yes, right. Okay. Under constant physical conditions, the current flowing through any material is directly proportional to the potential difference. So the basic necessity for the current to flow through any material or in any circuit, that is to give a potential difference. This potential difference is given by sources like cells, battery or any other power supply. So when you give potential difference, current will be flowing. So Ohm's law states that the current flowing through any material or a circuit is directly proportional to the potential difference applied. While writing, we will write V proportional to I, and we can write V is equal to a constant R into I. We have defined this constant R as the resistance. So we defined the word resistance also the previous year. What was the definition? Previous class. What was the definition? Yes, it is the opposition for the flow of current. Any material, when we allow electric current to pass through it, it will resist. How it will resist? By virtue of its nature. By virtue of the nature of that material, the material will resist the flow of charges through it. So that resistive property, that is called as resistance. In physics, we will be naming it as resistance. So here the constant of proportionality is called as resistance of the material. Therefore we got the equation V is equal to R into I. Now, as I told you in the previous class, this relation V is equal to Ri, giving us a valuable information as V proportional to I. Means when you give a potential difference, that potential difference, if it is increasing, the current will also increase. If this is decreasing, the current will also decrease. That is the meaning of direct proportionality. That's why we are writing V proportional I. So, if you make a small circuit where a particular material having a particular resistance, if we allow current to pass through it, we can verify this law. Whether the current flowing through that material is increasing or decreasing with respect to this potential difference what you are giving. That will give us a proof for the Ohm's law. So that we have to study under the verification of Ohm's law. So I just told that day we have to use a device named ammeter. A device named ammeter to measure current. And a device named voltmeter to measure the potential difference. These are devices which can be used for measuring current and potential difference. So I mentioned that when we measure current, this device should be connected in series, and when we measure the potential difference across any 2 points, this device should be connected in parallel. So what is this parallel and series connection? You can compare it with a chain. See, I am wearing a chain here. The beads what you are seeing here, one after the other, these beads are connected one after the other. That connection can be called as a series connection. Whereas this pendant here, this is a parallel connection. So in the chain, the pendant, we can say that the pendant is a parallel connection, whereas the beads one after the other when you are connecting, that can be a series connection. So how some things will be connected series, some things will be connected parallel. If you have connections one after the other, like flowers in a thread, like that if you are connecting, that would be a series connection. And as a pendant or a locket, if you are making something, that will become a parallel connection. So let us make the familiarity with these devices. These devices are available in our lab. I will show you how an ammeter is looking like and how a voltmeter is. And when you measure the potential difference and the current in a particular circuit, you have to adjust the voltage, adjust the current. So what else device we will be using there? Their symbols, all these things I will explain you. So this ammeter usually will be referred in a circuit as letter A inside a circle with the two terminals, and the voltmeter will be referred inside a circle with the two terminals. A resistance will be symbolized with a zigzag line, the resistance, and the cell will be denoted with the big line and the small line. Big line corresponding to the positive terminal and the small line corresponds to the negative terminal. And in addition to this, wherever we are seeing the electric circuits, we can see switches. So in the lab, the switch what we are using, that will be not called as switch. It will be denoted by the letter K, and that is called as key. The switch is called as key. So here this is the positive, this is negative, and this can be a resistor. So if you put a dot here, meaning is that the switch is inserted or switch is closed. This is a closed circuit. That means the current is flowing. So to represent the switch, two small brackets, inside that if you are putting a dot, that denotes that the circuit is closed. That means you have switched on the circuit or the current is flowing in the circuit. And in addition to this, these are the things which we require according to this physical quantities what we have to measure. In addition to this, to adjust the current, we will use another device. This is nothing but a variable resistor. So variable resistor, that means the resistance of that can be varied by adjusting its length, and this device is called as a rheostat. So this instrument we are using in the circuit, just for our convenience, we have to increase or decrease the potential difference. So what we have to do, actually speaking, one cell of 1.5 volt if you have connected, to increase the voltage of the circuit, one more cell you have to connect in series, then two more cells, three more cells, like that cells number either you have to increase or there should be some other mechanism for increasing the voltage. But with this steady or a constant voltage, if you use this device, this is a variable resistor. So just by increasing or decreasing the length of the resistance wire in that particular device, we can automatically adjust the current or the voltage in the circuit by increasing or decreasing the resistance. So for the convenience, we are using the rheostat. So I will show you which are these devices which are available in the lab as mentioned in the explanation. So this device you can see, this is voltmeter. You can see the letter V written there. So the device is used for measuring the potential difference. A needle is there and the red color stands for, red button is for the positive connection and the black is for the negative. So negative and positive terminal is mentioned with the red and the black buttons there. And if we use this, we can measure the potential difference. How this device will be connected? And this device will be connected in parallel. So you can, after coming to the school, you can do this experiment in the lab. So the next device is ammeter. The ammeter is also having the similar kind of an appearance, but the letter A is written there. A stands for ammeter or ampere, and this again you can see here the positive and negative. The positive and negative, positive is the red color and the negative is the black color switch, and positive and negative we can give the connection according to the need of the circuit. And this is ammeter. And as I told you, the device rheostat. This is rheostat. You see here, this key you can slide over this, and if you closely observe, you can find that there are wires of many number of turns. So this windings of the wire can be used to increase or decrease the length of the wire, therefore the resistance can be varied. Here you can make a connection and here also you can make a connection. So the entire length of this wounded wire will be acting as a variable resistor. So this we can use to adjust the current or the voltage in the circuit. And the key what we are using, the appearance of the key will be like this. The key will also have two terminals to connect, and if you remove this is open circuit, and if you insert, the circuit is closed. So if you insert this key, that dot we have to put there. So this is a single key in the circuit, and the resistance wires what we are using, it is available as rolls like this. From here a convenient length of the wire you can cut, and this we can cut and we can use. This is the resistance wire. And the power supply what we are using, that will be used with the help of an eliminator. This is called as battery eliminator. This device is used to reduce the voltage. At the same time, whatever available in our power supply is AC, that will be converted to DC of desired value. So here you can see the voltage varies from 2 to 12 volt in this eliminator. So we can have the low value of 2, 4, 6, 8, 10, 12 like that. The lowest value of the DC volt we can get from this eliminator. So AC can be converted to DC, and also we can have the particular value of the desired voltage from this device. So with these many devices we can make a circuit. So how we will make the circuit? So to connect all these things in a circuit, we have to design. How we will design the circuit? So with all sorts of precautions what you have learned in the previous class, we have to design. So we have to take the resistor, then this resistor must be connected to the ammeter for measuring the current, and the current is passing through this resistor with the help of a battery, the positive and the negative terminal. This should have an operating system. That operating system we can operate the circuit with the help of a key. So if you connect, this has become a complete circuit, but current will not flow through the circuit. Why? Because you have not closed this. If you close the key, the current will pass through. This is resistor. Since this is positive terminal, this ammeter positive terminal you have to connect the negative terminal back via key to the negative terminal. This much of the connection, these many devices connected in the circuit in series. You see, one after the other. We have to connect one more device. What is that? Yes, the voltmeter. The voltmeter we have to connect where across the resistor. Here you are measuring the potential difference. Therefore, you have to connect the voltmeter here. So this is appearing like the locket or the pendant of the chain. Yes. So here you have to put the positive, and here you have to connect the negative. So battery positive should go there and the negative should come back. So this is a basic Ohm's law circuit. Ohm's law circuit. So using this circuit, we can measure. What we can do? Actually, this is a steady circuit. So there is one resistor is fixed, and ammeter is connected, battery is connected, voltmeter is there, key is there. So if this battery is giving 4 volt, then across this resistor also with slightly reduced value, we will get that volt only. How we will repeat, how we will verify this? Verification of any law means we have to use different conditions. So we wanted to change the value of V. How we will change? Because you have fixed this. That's why I told you we can have the device which is called as rheostat. If you include rheostat in the circuit, sliding that rheostat, we can change the value of V, hence we can measure I, or we can change the value of current I, we can measure the value of V. So what we have to include here, so this is a steady circuit with the steady value of V. To make the changes of the potential difference, we have to connect a rheostat. There is no difference positive and negative terminal because it is just a resistor, no positive negative terminal, you can connect either way. So if you include rheostat here, by sliding that rheostat, you can vary the value of V and hence the current. So what we will do? So the circuit is there, all the symbols I have explained to you, and we have to verify this Ohm's law. So to verify that, what we actually do, as I told you, fix the position of the rheostat at one point, see the voltmeter, and before connecting you should study the voltmeter. How can you read? Just like your scale, what you are using in the day-to-day classroom activities, you use to scale in mathematics also, like that. How to read or how to take the readings from the voltmeter, that you have to note. And from the voltmeter, you take the reading. It may be something 0.5 volt or 0.4 volt, like that. Correspondingly, take the reading from the ammeter. Similarly, if you want to change, what change you can make? Rheostat can be adjusted. The key over the rheostat, you slide over it. Therefore, the value of V will change. You will get a new value of V. Correspondingly, you can measure the current. Similarly, you repeat it for 4 or 5 times and make a tabular column. And this tabular column, what are the things you have to include? Serial number, V value, I value, and you should find the V value, I value, and we should find the value of R as the ratio of V to I. V always you put measuring volt, this you measure in, and then the resistance you will get in ohms. 1, 2, 3, 4, 5 or more than this. Many times you can repeat and you can verify. So what is your expectation? When we are telling V is proportional to I and V is equal to R into I, this material we have fixed here. So this resistance we are measuring. You have connected it already. So when whatever we change the value of V, correspondingly the current will change, but the resistance will remain as a constant. So R will remain constant. The V and I will mutually adjust. V increases, I will also increase. If V is 0.5 volt, I can be 0.1 ampere. Therefore, you will be getting a value of resistance. So that how much it will be, resistance will be 0.5 by 0.1, it will be 5 ohms. So similarly, next if you take it as another value of V, I will also change. Again the resistance value will remain as 5 ohm itself if this value is 5 ohm. So the resistance value will remain constant, and that we can measure as V divided by I. This we have to verify in the lab. I will demonstrate how you have to take the readings and how you can measure the particular value of V or current in the laboratory. After taking the readings, we have to draw a graph. What is that graph? Graph between the potential difference and the current. So if you draw a graph taking potential difference along the x-axis and current along the y-axis for different values of V, different values of I, we will be able to get a graph. So what is this statement? V is directly proportional to I. Therefore, if you plot a graph, you will get points in such a manner that this will be a straight line. You will get a straight line graph. The VI graph will be a straight line, again showing that V is directly proportional to I, and V by I will remain as a constant, which gives the resistance of the material. Let us perform the experiment. So to have a better view, I have redrawn the circuit on the slide, and I think it is very clear now. The other diagram which I have drawn on the board, if it is not clear, you can refer this. There may be slight difference between this diagram and that diagram, because the ammeter and the resistor I have connected to this end of the circuit, but that doesn't make any difference, because all these things, as I told you, it is connected in series. In a picture you can represent it anywhere. This ammeter is coming here and the key is coming back here, that doesn't matter. As I told you, one after the other, ammeter, resistor, rheostat, key and the battery you have to connect. So make sure that the positive terminal of the battery is connected to the positive terminal of the ammeter, and the negative terminal to the other end of the resistor. Same point you have to connect the voltmeter, so that the voltmeter will appear parallel to the resistor. So this part you have to take care. And when you make a circuit, the arrow mark, so arrow mark must be marked, which is showing the direction of the current. So as I explained in the previous class, the direction of the current is from positive terminal towards the negative terminal. So this here the arrow mark downward and here arrow mark upward. So I hope all of you understood this circuit diagram. You can draw this diagram in your book, because the same diagram is not available in your NCERT textbook. So there, instead of using a rheostat, they have given a variable voltage. That circuit they have given. So instead of that, you can use this, because practically in the lab we will be using this circuit to verify the Ohm's law. So are you ready for the practical experiment? So let us go and do the experiment in reality. This is a circuit diagram. So how we can use the instruments to measure all these things, let us see. So this is a practical setup for measuring the voltage and the current. So this can be used for finding the current in the circuit as well as the potential difference. So this is battery eliminator, and it will be giving the desired DC voltages ranging from 2 to 12. Morning I have shown you. And when you place the knob of the battery eliminator to one particular direction, means pointing towards 2, the entire circuit voltage will become 2. Then if you change, it will become 4, or if you want to change it to 6, you can change. So the changes making in the knob, that will be making the particular value of voltage which you can select. The positive terminal is connected to the positive terminal, negative to the resistance, and the other end of the resistance is connected to the rheostat top, and the rheostat, the other end, the bottom end, that is connected to the key back to the battery eliminator, that is to the negative. This is a series circuit. This resistance box, small black color box, it is a replacement of the coiled wire which I have shown in the other part of the explanation. So this resistance always connect in parallel to the voltmeter. So as I have explained you, it must be parallel. The resistance must be parallel to the voltmeter. Then only we can measure the potential difference across the two ends. So two ends of the voltmeter must be connected to the two ends of the resistor. So now the needles are not moving. So this is the experimental setup. So we have inserted the key. As I told you, it is a closed circuit, but we are not able to see any kind of movements in the needle. So what we have to do, actually we have to switch on the current. So this rheostat, as I told you, we can slide. That sliding key If we fix at one point, the resistance of that variable resistor or the rheostat, that will change, so that we can increase or decrease the value of V, the value of voltage, and hence we can measure the corresponding value of current in the ammeter. So that is the way how we are going to do the experiment. Fix the position of the rheostat, then measure the value of V, then measure the value of the current. So to start with, we have to switch on the battery. So when you switch on the battery, we can see that the needle will be moving, and the needles of the voltmeter and the ammeter, very carefully you have to find what reading it is giving. So when you increase or decrease the value of the resistance from the rheostat, the V or I from the voltmeter or the ammeter, that will change. So how to measure that? Before switching on the power supply, you have to study the scale of this. So when you study the scale of this, what will happen? The one division, if it measures one particular value, when the needle is coming to 5 division or 4 division, then that value of one division into the number of divisions what is showing by the needle, that will be the reading which is given by the instrument. So slightly we have to move this rheostat, that part also you take care. So the readings similarly in the voltmeter as well as the ammeter, we have to tabulate in a tabular column also. So now when we increase the value of the resistance, what is happening? The current will be getting decreased. Or when we slide to this side, we are decreasing the value of the resistance, so that you can see that ammeter is showing an increase of the current. The needle will moving from 0 to an increased value. So actually there we are decreasing the resistance. So let us, from that end to this end, let us decrease the value of the resistor of the variable resistor. Then let us measure the value of current. Let us switch on. Yes, the red light shows that the power supply is on. Now you see the needles. The needle has come to this point, and the needle has come to the one particular value, so that what we can measure. So I hope you will not be able to see the readings, but in reality we will do this in the lab, then you can find. So ammeter is showing 3, so that is 0.3, 0.4, 0.5, 0.6 and 1, like that. And here also you can see the readings. So just a corresponding voltmeter reading and the ammeter reading we have to tabulate. So carefully measure V and I. Now next what you have to do? We have to change the position of the rheostat. So when you change the position of the rheostat, correspondingly the V and I will change. You see. Fix it to one particular point. Now measure the value of V and I. So first set of value, first reading, and this set of value we can have the second set of readings. Again push it to the other end so that V value should increase. Yes, and measure that value. Correspondingly, what is the value of the current we can measure. Again to repeat, again slide the key. Yes, sliding key of the rheostat you can push. Another value of V and another value of I. So how much maximum possible with the help of the rheostat, that much you can measure. When it is touching to the other end, further we cannot move. So the maximum end, so how much variation in the rheostat you can make, that many readings only you can measure. So push it to the other end completely. Yeah. Again you can see that the V value is increasing. I value also increased. Is this explaining the Ohm's law? Now you observe that as the value of V increased, I also has shown an increase. So is this the Ohm's law? V proportional to I. And V is directly proportional to I. That means V increases, I will also increase. So what next we have to do? So as I given in the tabular column, you have to tabulate these readings. You have to tabulate neatly, and after tabulating you have to draw a graph between V and I. So the x-axis you can take V, y-axis you can take the I. So keenly tabulate all these readings of V and I, and after proper tabulation we can find a graph and we can study the nature of the graph. So from the nature of the graph we can decide whether our law is correct or wrong. So if V is directly proportional to I, such a direct proportionality quantities should fetch you what kind of a graph? A straight line, means starting from origin 0 to 0, that is origin 0 and 0, ammeter reading 0, voltmeter reading 0, from there the highest value. So if you plot, the graph must come as a straight line with a slope. So this is the last reading possible from our setup, so that our rheostat is giving this is the highest reading, and further we cannot change the value of V, and hence we cannot measure the value of the current. This is the maximum possible. Between the minimum and the maximum, how many possible readings? So not less than 5. So that many you have to measure. So 1 or 2 measuring means error will become more. Anyway, when you take the readings from this kind of devices, there will be occurring definitely certain errors. So these errors can be rectified if you take or if you repeat the number of times. How many times you are repeating the experiment, that much error can be reduced. So within this limit and 0 to the maximum, let us take 5 readings. So the first case, voltmeter reading was 1, then it was 0.2. So if you plot a graph, the graph will be giving a straight line.